In this video, we're going to take a look at graphing radical functions. So the parent function for our radical function is y equals the square root of x. So notice nothing is added or subtracted, nothing fancy. It's just our basic parent function. It's also called a square root function. So let's plot some points, fill in our table, get some more information filled in. So in our table, we've already got x values of 0, 4, 9, and 16. So let's take the square root of each one to get our y value. So the square root of 0 is just 0. The square root of 4 is equal to 2. The square root of 9 is equal to 3. And the square root of 16 is equal to 4. So I intentionally picked some values that are pretty simple to work with. Now let's plot these on our graph. So we have the point 0, 0. We have 4, 2. 9, 3, and then 16, 4 would be slightly off of our graph, but we can draw a good estimate of our graph. So the domain for this graph, let's take a look, would be the x values are greater than or equal to 0. So we'd say x is greater than or equal to 0. It's just not any negative values, because notice we can't take the square root of a negative. And then the range is actually the same. Notice our range starts at 0 for our y value, and then it goes up. So y is also greater than or equal to 0. So let's take a look at transformations of radical functions. So when we have the form of a radical function and some things have been added to the parent function, they have a different effect on our graph for each one of these things. So the sign in the front, just like normal, would make our radical function go up or down. So when it's positive, it kind of looks like that, and negative makes it go down, or like reflect over the x-axis is another way to think about it. And then, let's see, let me grab another color. The coefficient, so the value of a, determines the steepness of the graph, like a slope. So like when our graph is really steep, a is greater than 1. And when it's not as steep, then a is between 0 and 1. So it's like 1/2. So it's not as steep. And then, let's grab another color. It says that anything going on in here, and we normally look at just the h value, we would say is a horizontal shift. So when we have a positive h, it goes to the left that many units. And when we have a negative h, it actually goes to the right h units. Let me write this a little better. So minus h means it goes to the right h units. And then the sign of the x makes it open left or right. So if we ever did have a negative value for x, in other words, it would make it open to the left. But notice, like, most of ours are just going to open to the right, like these little sketches look right here. But if that sign was a negative, it would make it open the other way. So it would go that way instead of to the right. And then the very last part we've looked at before with our transformations is k. K makes it have a vertical shift. So if you have a positive k, it goes up, and a negative k would make it go down.